Hello again, it's me. So now we're gonna solve another problem. But before we start solving this, and this problem is about waves, it's about sound, a sound wave. So please pause the video and try to read the question and answer it. And let me tell you, that was given to you in the monthly exam. So pause the video, please. Oh, you're not planning to do so. Well, anyway, I will start working on that, believing that or hoping that you did pause the video and try to solve it, okay? So here they're asking us, this is, oh, by the way, this is a screen of an oscilloscope, which is a device, an electric device used to give us a visual image of the wave, okay? So that we can do some physics on it. And now we're gonna talk about, the question is here is mark the following on the diagram. And the first one is about lambda, right? Which is the wavelength. And let me tell you about Miss Wave before starting with lambda. This is Miss Wave. This is one wave. And now this one, let me do it that way. This one is another Miss Wave, but we're not concerned about her right now. We only want to work with the blue wave. This from here to here, this is one wave. Now asking about lambda is the same as asking how tall is Miss Wave. She is lambda meter. That's her tall. That's her length. Like this is her. Yeah, if you ask her how tall is she. So you got it. Lambda is the length of a wave. And this is one way of looking at it. There's another way of finding lambda, but I'm going to talk about it after we solve the other two, okay? So starting with this is lambda. Let me just clean it for you here. So this is lambda. Now the second one is asking about the amplitude. Yeah, this is the amplitude. Amplitude is the highest distance that the particles can get to. This is the highest distance. By the way, this is the highest distance as well. So if you mark this as the amplitude, I'll give you a full mark as well. Again, this is the highest distance as well, displacement. This is the highest, highest of the particles, but I don't want to talk about this right now. So let's just say that it is this point or this point or this point. All are A. All are the amplitude of the wave. I think most of you got that correctly. So now we're going to the crest. Let's clean again. The crest is the top. So instead of saying top and bottom, in the wave language, we call this crest, we call this trough. Okay, this is the crest is the top, or the top point of the wave, and we can say that the amplitude is the distance between the resting point here, until the crest up there. Okay, here, this is the trough. You don't have to really answer this because only asking about the crest here. So I think now this question is easy, right? So let me tell you another way of finding lambda. Lambda has a lot of way to be found, because basically lambda is the distance between a certain or a particular point in a wave and the same point on the next wave. Now we know that, let me draw them again. This is the first wave, and this is the second wave. We have two waves here. Let's use another color. Yeah, pink. So we have two waves here, and this is the crest. I choose crest as my first point, and the distance between this crest and the crest on the next page is lambda. So we have a lot of ways to find lambda. It's either crest from the distance between two crests, or the distance between two throws, or the distance between the start of the first wave and the start of the next wave. All of these are lambda. Now, if you choose any of them, you get the full mark. You don't have to write them all. Just choose any of them and you're gonna get the full mark. And now we're done. Let's just write it again for you. Let's go with blue again. So from here to here is lambda. From here to here is A. And this is the crest. That's the answer for the part A. Now let's go to part B. The picture of a sound wave seen on an oscilloscope has a frequency of 200. So F is equal to 200 hertz. What is the time period of the wave? They're asking about T. And we know that there is an equation that is connecting those two. So if you have it, you're gonna have it in the table attached with your paper, with your exam paper, but I can't remember if it's 1 over T or the other way around. So if it's not the way you want it, just do this mathematical trick and you're gonna get T is equal to 1 over F, or over the frequency. This is the F. So T is equal to 1, this is 1, not I, 1 over, just substitute it and write F here. And now use your calculator and it's gonna be something like 0.05 seconds. Yep, that was the answer for it. Easy, right? So let's go to the next question. Oh, we have the next question here. So next question is asking about if the speed of sound in air is, so they're gonna give us the speed as 340 meters per second. Calculate the wavelength. They're asking about lambda, but you know, we have, let me draw it somewhere here. Okay, here. You remember that one? V is equal to F. Oh, that's not clear, right? So let's write it here. V is equal to F times lambda. And again, it's going to be given to you in the exam, but let's just write it here, F times lambda. However, we need lambda. We don't need the V right now. So lambda has to be alone in this, in the left side. So again, it's mathematical trick again. So just V over F. Anything that is multiplied with lambda is going to be divided, V is going to be over F. So yeah, if you have any problem with math, ask me in the chat. But I know that it's not going to be difficult for you, right? So V here, you just change that. My V is not very beautifully written, so let's fix that. Yeah. And yeah, so just put the V here and you don't have to worry about anything, because the V here and also the hertz here, the frequency here, both are in the right units. We don't have to convert anything. Nice. So just 340 over the F, which is here the F. Now the F is not given to you in this part, but you know, all of this is one question. So you can gather information throughout all the questions. Usually when they ask you ABC questions, you will be needing some of the information you gathered in AB. Okay, so you just use the frequency you got in B, in here, which is 200, and use your calculator and see what is the answer. And yeah, it is 1.7 meter. Easy, right? I hope you understand it, and if there's anything that you couldn't, let me see if we have another one. Everything is clear. I'll see you in the next one.